Guys, today I will be presenting on wind resistant building design towards saving lives and property. My name is Alvaro Gira, and let's get into the presentation. Basically, wind pressure. What is wind? Wind can be defined as the movement of air, and basically we'll be focusing on wind pressure, and we will be focusing on its velocity, whereby they can be from 0 to 1.5 meters per second when wind is basically hardly noticeable, or there are basically no effects, to speeds in excess of 24 meters per second, such as cyclones or hurricanes, when considerable damage to property and discomfort to persons can be the result. So winds have an immense amount of power and cannot be overlooked. As you can see a picture on your bottom right, which shows a house and the way in which the wind operates or wind pressure operates. Basically, we have the positive pressure that hits on the faces of the building, and then the wind then makes its way around the building to the rear end of the building, and this is known as negative pressure and causes a suction effect, as I will be showing you very shortly. As you can see in this picture on your top left is what I was basically showing you a while ago. This is the plan view of a building, and as you can see how the wind operates or wind pressures operate, they hit the face of the building, and then the wind makes basically its way around the entirety of the building to the rear end, and the pressure accumulates there and provides a suction effect. So this is basically how wind operates in respect to buildings. Next, factors to be taken into account before the magnitude and direction of wind pressures can be determined. These include the height to width ratio of the building and the length to width ratio of the building. This basically means, of course, the bigger, the wider your building, the taller your building. All this plays a role because this will determine how much wind comes bashing at the face of your building, also how much wind tends to accumulate at the rear end of your building and provide a suction effect. So these are factors to be taken into account. Next, the plan shape of the building. Basically, this means the shape of the building. I will be showing you a short video at the end of this presentation, which basically illustrates this, whereby people are now using buildings designed in the shape of circles or a circular shape, in which this provides very good resistance to wind pressure, whereby basically the wind hits the face of the building, but due to its shape, it tends to go around, and the wind really has no area in which it can provide a very good significant suction effect. So this is a very good wind resistant building design. Next, the approach topography, exposure of the building, and the proximity of surrounding structures. Basically, topography of any land basically means the way in which the land's shape. This would also incorporate any slopes the land may have, and this affects the wind pressure, because if you have a slope or a hill in the land, it would kind of mitigate the pressure of the wind. Also, the exposure of the building, whereby this talks about the any obstructions in the area, such as trees or rocks and so forth, and the proximity of surrounding structures. So if you have a lot of structures in that area and your building is not completely exposed, therefore that may help mitigate the effects of the wind pressure onto your building. Next, Account must also be taken of any likely openings in the building. This is very important, and this is a reason for which during hurricanes or before hurricanes you may notice people putting cladding onto their window openings, and this is basically to protect your openings and the window itself in the case the window breaks. No materials will come barging into your opening. Also, this prevents suction effects from creating inside that opening, which can help give the wind pressure a more significant strength and later on create damage to your building. All buildings are at some time subjected to wind pressure, but of course, the more vulnerable, which would be maybe which would take in account their shape and their exposure or method of construction. Their shape, as we mentioned before, some buildings are now being built with a circular shape, which helps to mitigate that wind pressure. And also the exposure or method of construction, where good workmanship plays a huge role. Therefore, incorporating very good techniques into your building construction helps a lot in order to prevent any damage or loss due to poor workmanship. To overcome the problem of uplift, and uplift basically means your roof coverings and so forth, whereby wind would accumulate at the bottom and try to rip your coverings off of the structural frame, which is your purlins, or also known as your lat board. So proper anchorage is recommended in that area in order to prevent that uplift from occurring. Next, the immense destructive power of wind in the context of building works cannot be overemphasized. And I cannot stress this enough because wind has very significant damage and strength. And as I will be showing you in the next slide, you will be surprised if wind can basically rip a tree off its roots. What do you think it can do to a house, a wooden house? So for this reason, you cannot overlook the strength of wind. So you need to incorporate all the necessary adjustments in order to withstand that pressure. As I mentioned before, here you can see two pictures showing the immense destructive power of wind and why they cannot be overemphasized. Therefore, in the building design, good wind performance depends in basically the design, and all the details and specifications, whereby the materials and their application play a huge role. The good durability of materials, also the maintenance and repair. Therefore, you would want to take these necessary steps in order to make sure the building could take up the necessary or they could take up the wind pressures. So step 1, basically calculate all the loads or wind resisting forces in that system, and this includes these structural members or elements, which include your beams, your columns, your shear walls, and diaphragms that provide the backbone of your building or the stability of the overall building itself. So calculation of the loads is your first step. You want to know all the loads of your structural members, the dead loads, everything that incorporates this. In order to take this information and take it to step 2, whereby you will determine the load resistance. As it states, after loads have been determined, it is necessary to determine a reasonable safety factor. Now, what do you mean by safety factor, you may ask? Well, this basically means preparing your building or designing your building so that the structural members would have sufficient strength as to not allow the wind pressure to exceed that strength or to cause failure. So proper stress design is very important. And as it says, for buildings envelope systems, a minimum safety factor of 2 is recommended. Next, for anchorage of exterior mounted mechanical, electrical, and so forth equipment, such as your satellite dishes and so forth, a minimum safety factor of 2 is recommended. And as follows, regardless of which approach is used, it is very much important that the designer ensures that it can be demonstrated that the structure can withstand all of this wind pressure. Step 3, detail design. And this is pretty much the most important step in all this process, because this incorporates almost everything. It incorporates all the decision making and so forth, details and the specification of the structural system, and therefore it requires appropriate decision making in order to assess and discuss the building's risk from high winds above. As you can see a picture at the bottom, which shows a building basically being uplifted, and the engineer basically needs to take all of this in account: uplift, rocking, and overturning loads, in order to help make the building proof to all of these effects, which wind can cause, of course. Step 4, durability. This is another very important step, because this incorporates basically the specifications of the materials that will be used into the building to help it make it wind resistant, as well as give it the adequate strength and protection, such as the ferrous metals that will be used in any building. And ferrous metals, as we all know, are prone to corrosion or rust. So if in any case an alternative metal can be used, such as stainless steel, it would be the best way to go. And in some locales, such as termites, in the case you are building a wooden structure and termites is a problem and it can affect your building performance, it is recommended that this will be treated with a pesticide applied by a professional, of course, and someone that is experienced in termite treatment, in order to allow these effects to be mitigated completely. The durability of materials are particularly important for components that are concealed. What does this mean? For example, let's say you are working on a building and you have your beam spanning on your building, right? Okay. On the finishing touches, you would want to add a drop ceiling, which would eventually cover the faces or the exposure of the beams, which are the structural members. So in that case, any failure of the beam would not be seen, and this poses a very big threat, because it is not something that you'll be able to see. So in this case, proper consideration must be taken, and following all the detailed specifications should be done in order to make the beam able to withstand and all the pressures that may accompany it, in order to prevent any later on failure. Step 5, rain penetration. And this is a very overlooked one as well, but it's very important, since rain or drops of water, or water basically, always will seek its level. Therefore, water may seep into tiny cracks or openings or holes in a building, and it can cause molds and also penetration of wind-driven rain. So proper design of the resistance to water should be taken, and consideration should also be taken to minimize water damage in this case. And here we'll be showing you a very nice video of what we mentioned before, where buildings are being made of circular shapes in order to mitigate the adverse effects of wind pressure.
Year after year, storm after storm, these were the homes that were left standing, and people said, if I'm going to build in a hurricane zone, this is what I want.
Our homes are exceptionally strong because we use materials that are very high quality. They're often designed for high wind zones, and high quality material you can't just go to the store and buy. Our home is panelized, so we're pre-manufacturing sections of it in a factory and then shipping it out to you on the job site. Our round design is actually a self-supporting roof system, so it doesn't have any interior load-bearing walls, which means that the inside can be laid out basically any way that you want.
Total devastation. We lost part of the roof and most of the ceiling, but I'm still alive, still here, kicking. I took pictures of this place and the whole neighborhood the day before. We were all out here, all the neighbors. They just had their new roofs installed from the hailstorm. And everybody was cleaning up. We were getting ready for the weekend of fun. And then Harvey, so everybody's like, okay, well, we're gonna leave. Because most of those people are vacation people. They don't live here full time, not like us.
Hurricane Harvey barreling into the Texas coastline. Storm surges are predicted to reach up to 12 feet.
The city of Rockport, Texas is right in Harvey's path and is getting hit hard.
I felt like this is a nuclear war had happened here and my neighbors had been bombed. It was heart and gut wrenching to see the damage that a lot of people have suffered through, and their whole life is forever changed by this.
Climate change is something that is hard to not think about when you see hurricane after hurricane after hurricane, the wildfires that have just hit California. It really makes you think about, if I'm going to build a home, what is it going to be like 20 years from now, 50 years from now, 100 years from now? I'm not just designing for today, but I'm designing for generations into the future. And what's it going to take to make sure that we resist those things?
Having a lot that was, half a block from the water, we thought we really need something that is hurricane resistant, and this roundhouse concept they can't bill as hurricane proof, but when you look through the gallery of pictures, there sure are a lot of pictures, as ours is now, of the Deltec house standing tall while everything around it is shattered.
I think resilience, like passive survivability, is the concept of, building a home that can withstand all kinds of weather extremes is something that we have been really good at, and I want us to keep improving in that direction.
Obviously, this round shape makes sense in a high wind environment, and we're able to get a lot less pressure building up on that home just because of that design. But how do we go above and beyond that, beyond just the shape? How do we engineer that to be even stronger? And so you see this, what we call radial engineering, where it's like spokes on a wheel, and the entire home is like this wheel that it works together, so the entire system is set up to resist those high winds. There really is nothing about what we do that is rocket science. It is a simple concept, and we've really perfected it over the last 50 years in the way that everything fits together and works together. And to me, what's really special about the Deltec is there's this combination of science and sort of, high-tech manufacturing, but then it blends so well with, what I call the old world craftsmanship. We're building this home, it's out of wood. It's not like it's some new high-tech material, but the way that it performs is above and beyond really what any other wood home can do.
Well, guys, I'd like to thank you so much for your attention. And this was my presentation.